Welcome to the ET335 SOP Karnaugh maps, also known as some of the products, and the engineers call these min terms. Here we're looking at standard forms of Boolean equations. So there are two of them. SOP is sum of the products, which means addition of the multiplied, which means that we have AND gates feeding into one common OR gate. Okay. Here's the other standard form of Boolean equations, is the product of the sums, which means multiplication of the added. So we have OR gates feeding into a common AND, and we'll cover those next lesson. Okay, here we have our sum of the products, and we're going to go through the rules of Boolean algebra. A plus A equals A plus A bar equals 1, A plus 1 equals 1, and A plus 0 equals A. So what we've done is spread these out, and what we have down here is contradictory variables. A B plus a B bar cancels out, and that is the underlying thinking of Karnaugh maps. So right now we have just left with B. So what we're looking for is contradictory variables that will cancel out. Okay, so we have our SOP Karnaugh map here, and this is a 2x4. And what we've done is we've set it up as each one of these are only one contradictory variable different. That's why we count from 0, 1, 3, 2. So we swapped these two so that we could get the contradictory variables next to each other. So 0 and 1 is no problem. So this chart, when we go across the top and we go across the bottom, and we could fold this up like a tube, because this and this are contradictory variables, and the top and the bottom here are contradictory variables. So let's go ahead and evaluate that, and the easiest way to do that, because most of the time they don't put our Boolean equation in each box. So let's go ahead and see if we could evaluate this. So we want to evaluate it to a 1, 1, 0, 1, 0, 0, 0, because all bars, that's going to be 1 times 1 times 1, which becomes a 1. So we've got a 0, 1, 0, and we have 1, 1, 1. So all those are going to evaluate out as a 1. So let's go ahead and map it. So first one we have 1, 0, 1. So we're going to put a 1 in here. Okay, and the next one is 0, 0, 0. So we have 0, 0, and C is 0. So we're going to put a 1 there. And we have 0, 1, 0. So we're going to put a 1 here. And we have 1, 1, 1. So we're going to put a 1 here. Okay, there we've got it mapped out. Okay, so I have a little CAD drawing here, and I color coded it. So 1, 0, 1 is over here, 0, 0, 0 is up here, and 1, 0, 1 is here, and 1, 1, 1 is here. Good. Here we have a 4x4 Karnaugh map, and we're going to count the same way, 0, 1, 3, 1. So we have contradictory variables in this direction. So we're also going to do the same on the top, 0, 1, 3, 2. So this is AB and this is CD. Again, the top and the bottom row are contradictory to each other. So here we have side to side are also contradictory. So we could think of this as a pillow and sew it up, and those will be contradictory. So let's go ahead and map it. Again, we're looking for 1s. So we have a 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, and 0, 0, 0, 0. So let's go ahead and map it. 0, 1, 0, 0. So we're going to put a 1 here. And then we have a 1, 1, 1, 1, 0. We're going to put a 1 over here. And 0, 1, 1, 1 here. And 0, 0. And we've got a 1 there. And that looks pretty good. Here we have our answer, and it looks correct. So we got 1, 0, 0. Here's red. Green, 1, 1, 1, 0. Oops. And we've got 0, 0, 0. And our blue would be 0, 1, 1, 1. Looks good. Okay, so let's do another one here. So we have a SOP Karnaugh map 2 by 2. So let's go ahead and plot it again. So we have one, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, and 1, 1, 0. So let's go ahead and plot them. 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, and 1, 1, 0. Good. Okay, here's our pretty example, so it looks correct. Okay, let's plot the 4 by 4 here. So we have a 1, 1, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, and 1, 0, 1, 1. So let's plot it. So we have 1, 1, 0, 0. Then we have 1, 0, 1, 0. And then we have 0, 0, 1, 1. Don't you even think? Yeah, there we go. 1. And then we have 0, 0, 0, 1. And 1, 0, 1, 1. Good. All right, here's our colorful answer, and it looks like we got it. Okay, once we've got everything plotted, we need to look for pairs that are contradictory. So here we have 4. Okay, and what we're looking for is things that don't change. Anything that changes is contradictory and it drops out. Okay, so here B changes, it's gone. A bar stays, and then C and C bar drop out. So 4s in a 2 by 4 will end up with 1 variable. And the same long ways, we're checking for things that stay, and it looks like we have an A that's gone, and B that's gone, and it looks like the only thing that stays is C. Okay, here we have a single one. If it's single, it has to stay the same way, and we got to put it in the final equation because it's one of our elements. So if we have 3, we could only get pairs. All right, so A and C, B and B bar drop out. So here we have a contradictory pair, so A and B bar stick in, and then C's gone. And we have 2 here, and we're going to get A and B bar. C and C bar are going to cancel out. Okay, so as we said, we have a top bar and a bottom layer. These are all contradictory. Okay, so the only thing that remains here the same is B bar, so we're going to hang on to him. These two are also contradictory, top and bottom, and A bar's gone, B bar's going to stay, and C is going to stay. Okay, here we got our 4s. So if it's a 1 by itself, it's going to stay as original. And if we have 4, we're going to get a 2 variable term. Okay, so A stays, B stays, and then we have C, C bar, D bar, and D, so those are going to drop out. Okay, so if we have an 8 variables, we're going to get 1 remaining. So A is going to stay, B bar is gone, C bar and C are gone, D bar and D are gone. So the only thing is left is A. Okay, here we have 4s, and they're going to be 2 terms. So we have A and A bar is gone, B is going to stick around, C bar is going to stick around, and D bar, so they cancel out. So only B and C bar last. So here we have A, B stay, and then we have C and C stays, and then D bar drop out. And again, top and bottom are contradictory, and we're going to lose an A because we have A bar and A. And here we have 8, top row and bottom row. Those are still contradictory, and everything's, the only thing that stays the same is B bar. Everything else is gone. And we have contradictory terms, top and bottom. So A and A bar are gone, and D bar gone. So only leaving B and C.